Welcome to Brain Vision.
So this is problem 8.3. Here we have several objects that are moving in the plane, and we're told their masses and their speeds and shown what the directions of their velocities are. And so now what we want to do is find what the net momentum for various combinations of these objects is. So first for A and C, what is the net momentum for those two? B and C, and then all three of them considered together as a system. So the most logical place to start is just with getting an expression for the momentum of each of these individually, and then we just add up our expressions instead of trying to, going to the bother of, doing some of these more than once. So for object A, we can see it has a mass of 5 kilograms. It's going at 11 meters per second. P equals mv, so we know that the magnitude of the momentum is 55 kilogram meters per second, and we can see it's moving in the negative y direction. It has no x component. So negative, because it's going down, 55 kilogram meters per second. Y hat, this is the same as J hat. I just like X, Y, and J hat better. For B, it's a little more interesting. You can see here the magnitude of the momentum is going to be 60 kilogram meters per second. And then this has both X and Y components. So the X component is going to be the cosine of this angle because it's conveniently measured from the positive X direction. And then the Y component will be the sine of our 60 degrees here in the Y direction. And so you run all those numbers through and we get 30 kilogram meters per second in the X direction and 52 kilogram meters per second in the Y direction. And then C itself is kind of boring again. 10 times 3, 30, negative X direction. Nothing too exciting. So now let's start adding these together. For adding A and C, we see that conveniently A only has a Y component and C only has an X component. So we basically just write them next to each other. Now for B and C, C has an X component. So let's look at what the X component of B is, and it turns out that they're equal in magnitude and opposite in direction. So those cancel out, and all we're left with is the Y component of B. And now for part C here, it's worth noting that we only have to add actually two things together, B and C, since we already have that, and then A. You could also take A and C and then add B. It works the same. Because addition is commutative and associative and everything. So A we see is negative 55 kilogram meters per second. In the y-hat direction, and to that we'll add our positive 52 kilogram meters per second. And so then this works out to be negative 3 kilogram meters per second in the y direction. So these are the things we were hoping to find, and indeed we have found them. There you go.